Hey guys, this is Multipro. We are going to be talking about expressions today. So, expression kind of how shows how to show something. So, if a person is very expressive, they're showing maybe their thoughts or their feelings or ideas. Um, so, we're going to cover two main things here today. And basically, they're kind of the same thing, just reverse order. We're going to go from expressions that may be written in text or someone could verbally give them to you. And then we're going to convert those into mathematical expressions. And then next step, we're going to learn how to do look at mathematical expressions and how to write that out in words and letters and numbers. So expressions, whether it's in text or whether it's in math, it's kind of like two different languages. Math is sort of like its own language, and it follows some very good rules that have been discovered over time. And this is what makes math so consistent and tidy, perhaps. And it's quite exciting. All right, so let's look at something here where we could use this. So let's say that you have a basketball court. And I'm not very good at drawing, but you can imagine. And here's half court line. And so, let's see here. A foul line here. And so we will be trying to figure out the perimeter of this court. And so someone said that this side is A and this side is B length. And this is a rectangle. So A is equal to both the top and the bottom side of the rectangle, and B is equal to the length of the left and the right side of the rectangle. Let's say that A is 94 feet and B is 50 feet. So we want to find the perimeter of the basketball court. So if you've ever seen a basketball court, you know it's fairly long in the A direction and not as wide in the B direction. And if you've ever ran up and down a basketball court playing basketball, it's quite exhausting. There's a lot of area there, but we won't talk about area quite yet of a rectangle. But let's try to find this perimeter. Okay, so we can write this a couple different ways. We can say 2 times A plus B. That's what the perimeter is equal to. Or we can say 2 times 94 feet plus 50 feet. Right? So let's add 94 plus 50. So we get 2 times 144 feet. So then this is 288 feet. So that is the perimeter of a basketball court. So basically what we did is we had the mathematical expression here of 2 times A plus B, and we plugged in what A was. A is 94 feet and B is 50 feet. And we followed PEMDAS. Please excuse my dear Aunt Sally. So we did the parenthetical first, and then we did the multiplication. So we added together 94 plus 50, and then we multiplied 2 times 144, and we came up with 288 feet. What is a variable? Well, in the above case that we had, A is a variable and B is a variable. So usually these are designated by a letter. So they can be any letter. A lot of common ones are A, B, C, excuse my voice, X, Y, or Z, and anywhere in between C and X. And you can even use other alphabets. For example, the Greek alphabet is used quite often. But we won't get into that at this point, but later on when we do other subjects, we will see such things. Alright, so let's take a look at some algebraic expressions. Now, algebraic expressions can be either by text or they can be by math, because algebra is a math. So let's give some examples. So one example would be like 7 times z. So that's an algebraic expression. Let's say we had 12 plus 40x. That's an algebraic expression. We can even have fractions. 1 plus y over a. We can even, we don't even have to write this the way we have for multiplication. We can say m multiplied by 20q. We can even say, if we're dividing, 2c is divided by 9ab. So we can write this many different ways. Let's talk about a couple more terms here. Let's talk about factors and product. Okay, so let's say in this previous expression where we had, well, let's just look at the AB part. And let's say we can write this multiple different ways, right? We can say AB. That's the same as A times B. That's the same as A parentheses B. That's the same as parenthesis A, close parenthesis, B. And that you can even say this is the same as open parentheses, close parentheses, open B, close parentheses. So there's multiple ways to write this. So let's just write AB is equal to, we'll just say 9. Has nothing to do with this earlier, so let's just choose a different number. Let's write 10. Okay, so A and B, these are called factors. And then to the right of the equation, equal sign, this is called a product. So the product is basically like the answer. Okay, now let's move on. And sometimes we have things that look like superscripts. So let's say that we have x to the e. And so this is called a power. Okay. And the x, the part that's normal text, that's not superscript, is called a base. And the e, this is called an exponent. So the way that you would say this is x to the e power. So if we said 3 to the 6. So let's say that this is 3 to the 6th power. And I should use all text. 3 to the 6th power. That's how you would write that in text. So what does this mean? What is 3 to the 6th power? Well, this is basically 3 to the 6th power is equal to 3 times 3 times 3 times 3 times 3 times 3. So this number, 3, the base is the number that's multiplied. And the exponent is the number of times that it is multiplied. So we have 1, 2, 3, 4, 5, 6 times here. Okay? All right. So let's say that I'm going to give you some text and we want to convert this into a mathematical expression. So let's say we have the product of 2 and y to the 2nd power. So product of 2 and y. So this would be 2 times y, and y is to the 2nd power. So if you see the word power, that's referring to the exponent. And 2 and y are multiplied against each other. Alright, so now let me give you something, and I want you to tell me how to write it in text. So let's say we have y times 4 to the 2nd power. So similar as we had up here text, we need to write this in text. So we would say the product of y and 4 to the 2nd power. Right? Because we have y times 4, and the 2nd power is 2. 2 is 2nd. All right. So let's look at some applications of this. Let's imagine that we have a circle. And at the center of this circle, measured to the outer part of the circle, let's say that this is r. And the reason why we're saying that's r, we're saying it's the radius of the circle. Okay, so we want to look for the area of the circle. So the way that we can write this is because, first of all, if we multiply pi, which is this symbol here, not the pie you eat, by the square of the radius. And remember, r is equal to radius. So if we take pi, we can multiply by that r to the second power. Pretty cool. Alright, let's do another geometry problem. Alright, we'll see if I can draw this. I'm not very good at drawing, but you have to use your imagination sometimes. Okay, so let's say that this has dimensions h for the height, L, let's use all capital letters, H, L, and W for the width. Okay, so we want to find the surface area of this. Okay, so we know that we have 1, 2, 3, 4, 5, 6 sides to this rectangular prism, right? So we can take, let me use a different color pen. We can take, for this area, and there's one on top and one on bottom, we can say 2 times L times W, because L times W is the width and there's 2 of them. Okay, and let's add this to another area. Now let's look at this one here. So we have L times, H times W. Okay, so we're going to say 2 times H times W. Alright, now we have, because there's one on the side nearest us and one on the far side. Now let's find the last bit of area, and we'll have to add that to this as well. So the last bit would be L times H. Can you tell me where L times H area would be on this? Alright, I hope you said this area. And it would also be on the back side. Okay, so since there's 2 of them, we'd have 2 times L times W. Okay, so this would be the same as writing the sum of twice the length and width Oh, we missed a word. Let me back up to the beginning here. Okay. The product of twice, because we need to multiply, right? Twice the length, and that's described by L, and width, that's W. Got a little sloppy here. Okay. Let's keep going, comma. The product of twice the height, which is h, or as my Indian friends would say, h, and width, so that's W, okay, comma, and we have the product of twice, because we have two sides, the length L and width. Two times LW. Oh, I think I've made a mistake. We are all human, so we all make mistakes. So I have W too many times. I saw I had width 3 times, and that's not correct. I should have height here, so that means this should have been an H. If you caught that already, thank you. So this should be height, H. So that's how you would write that out. Okay. So let's look at one last thing. So we have a square, and each length of side of the square is A. Okay, A is a positive whole number. That means it has no decimals, no fractions, and it's no negative sign. And so we want to find, let's see, let's write this out. Let's find A such that area and perimeter are the same. So we're going to move from an expression to an equation, because we're going to have an equal sign. So what's the area of this square? So you have each side, right? A times A. So you have the height multiplied by the width. So we could write this another way. We could write this as A squared, because this is like having a 1 and this is a 1. And if we have powers, when we multiply them, the base here stays the same, and you take the exponents and you add them. Okay? Now what's the perimeter of, so this was area. Perimeter, let's move this up so we don't get confused from our previous problem. Perimeter would be each of the four sides added together. A plus A plus A plus A. So what's another way to write this? Well, we have four A's, so we could say the product of 4 and A. So we could say 4A. So let's set this and this equal to each other. So let's say that A squared is equal to 4A. Okay. So how do we solve what A is? What number is A? That's what we're looking for, a whole positive number. So what we have to do here is we have to find something common on both sides. So what's common on both sides is both sides, they do not have a 4, but they both have an A. So the first one on the left here, this is A to the second power. And the one on the right is A to the first power. So let's see how we solve this. Earlier, when we were multiplying two numbers, A to the first times A to the first, we added when we multiply. But what do we do when we divide? We subtract. So let's divide both sides by A to the first. So what is 1 minus 1? That's 0. So then this becomes A to the 0. Well, what is something to the 0 power? When something is to the 0 power, it equals 1. So therefore this becomes 1. So then let's look at the left side. We have 2 minus 1 for the exponents. So that's equal to 1. So what is A to the first power? Well, anything to the first power is just itself. It's like looking in the mirror. It's A. So we will get rid of this. This becomes 1, A to, yep. And we'll move this down to 1. So that'll be A to the first power. That did something I did not want it to do. Yeah, there we go. It's trying to read my mind and did beyond what I asked. Okay, so then what is this equation looking like now? We have A to the first power, and we have 4 times 1. So this is basically, if we take A to the first power is just A, and 4 times 1, well, it's like looking in the mirror. It's itself. It's 4. Ah, we found the answer. A is equal to 4. So if you were able to figure this out, great job. Because this is actually something that I haven't taught you yet, but we're going to be covering in the future. And this leads into future sections. I'd like to thank you for watching MultiPro.